Good morning, Jan.
Michael, good morning.
Or good afternoon, good evening.
Yeah, here it's afternoon.
Yep.
My best wishes for 2022
Same to you as well,
and
sir.
and welcome in the year of Jinaga.
I like that. That has a good ring to
Uh,
it.
well, my wife is Chinese, and she always said every year has
Hmm.
a theme.
Mm-hmm.
Most of the time it's an animal.
Mm-hmm.
So let's make it different this year, and let's make it the year of Jinaga.
Excellent.
Uh,
Yes. Yeah.
that that should be possible.
Yeah. Indeed. It's an idea. It's an identity. Um, yeah. It's a wish, a hope, a vision.
Mhm. And it will,
Mm-hmm.
it will. Um, should be able to make something nice this year.
Yes,
So
indeed.
how was the holiday?
Oh, it was very good, very relaxing. Basically, since we had the big Christmas, we had a very small New Year's, and um, uh, I spent a lot of my time working on a puzzle that my wife got me for Christmas. Um, so just kind of zoning out doing that, and then the rest of the time we've been kind of doing a traditional Harry Potter uh, watch through. Um, Usually she only makes it through the second movie before giving up, and now we've gotten all the way through Order of the Phoenix. So
Been a bit, how do you call that? Watching?
yes, yeah. But the good thing is that while doing that, I can also be working, sitting on the laptop and um, working on things like the upcoming. I'm going to be doing a new Pluralsight course.
Okay.
So basically, getting back into the Entity Framework series. So with the EF Core 6, they were like, "Hey, we need people to put together content for EF Core 6."
Mm.
I was like, yeah, "I've got some experience doing that. I'll jump in there." And I'm thinking about SQL a lot right now, so it's and Link and
Yeah. There are so many subjects.
mm-hmm.
Yeah. So while you're watching television, you still do programming.
Yeah, yeah.
Oh no, I cannot do that.
Yeah, I mean it's slow going. That's true,
Uh,
um, but yeah, this one is Entity Framework 6, Entity Framework Core 6 best practices, um, and so um, I started out with just a bunch of research. Well, what are the best practices these days? What have we learned? And
yeah.
and going through Jeremy Lickness's posts and Julie Lerman's articles and figuring out, okay, this is what we've learned about a new framework. But then it's best practices, so that means opinions, right? That means
Yeah.
yeah, best is subjective. So I get to say this is better than that. This is a good place to start. But hey, this crazy idea right here, this is what I consider best practices. So I'm going to throw in a few things like only allow the application to insert, not update, not delete. Anyway, that's not a best practice, but it's if you were on my team, it would be.
There would be no update, no delete.
Exactly.
No update of the data, but update of the knowledge of the skills all the time.
Yes, yeah. We'll see if that one makes it through the review process of um, you know the outline. But yeah, there are a few things in there like yeah. Now there's a mechanism for configuring conventions that it's not quite to where they want it to be of custom conventions, but you can configure a conventional default for data types, for example. So you can say, all right, by default, I want all strings to be max length 100, um,
Okay.
which is better than the max length of just max string. Um,
Mhm.
and so my crazy wild opinion, which I put into practice on a project about 4 or 5 years ago was max length is 1. That way, if you forget to set the length, you're going to notice that pretty quickly.
There is still a better option. Use SQLite. There is no max length.
Mm.
It adapts itself.
Ah.
It will automatically allocate the amount of space that it needs.
Mm-hmm.
It is even not strongly typed. So actually everything, you can write whatever data type you want in whatever field.
Oh, okay. I did not realize that about SQLite.
Yeah, but so many people consider that as a bug
Mm-hmm.
that in one of the most recent versions, they added a feature called strict mode, where you do have to define your types.
Mm-hmm. Well, that does limit the implementation of indexing. Yeah, there are only certain indexes that could work that way.
What do you mean? Because of the limited types?
By having any data type in a column, I think that would mean that in a particular table you've got this column, but some of them are strings, some of them are integers, some of them are just.
Well, you assign a type affinity. So you say it's an integer, or it's a real, or it's text, or it's a blob. I think that's about it.
Okay.
And then, for example, for dates, you can store your date just as an international date string, but you can also store it, and that's the default mode, as a number of ticks. What is it? The unique
Since the epoch.
timestamp.
Yeah.
Yeah.
Okay. Yeah. Okay. So that basically is how they then selected the appropriate index algorithm.
But so it gives a certain flexibility. On the other hand, you have to be careful because if you switch to another database and you're going over the limits, SQLite will not complain. But let's see how it goes. I only read bad things from their competitors. Commercial competitors, they have a lot of negative critique about it, but most of the people like it. So
yeah, and it's the right thing for this particular job. Unequivocally, so. I don't think there's
I think
alternative.
So. I've been digging once more deeper and deeper in it, and I still haven't found anything that is not suitable. I will show you. Let's share the screen. Jinaga. Where is it here? Jinaga.net. Okay, go live. That's not readable.
No, that is small. Pretty small. Yeah.
Is that better?
Yes, it is.
Okay. Yeah. Like usual, I thought the customers will leave me quiet during the holiday. My children will leave me quiet, but no, none of them left me quiet. But okay, I still managed to do a little bit of work. Last time, so I had this with connection here. Yeah, so there nothing's changed, almost nothing changed. But I had trouble with this with transaction. At a certain moment, we were using the transaction object from the SQLite Net component. But so what I did was solve it just with the raw transaction comments, begin transaction, end transaction, and rollback.
Okay.
So I'm still using this SQLite.net library, but my intention is at a certain moment to leave it out. Now,
I see. Yeah.
That's an optimization. So I think that can wait. Let's first focus on the rest, and then in the end we can try to leave it out. Perhaps even that raw library, that is because so you have SQLite, a C-type library. On top you have this raw library which translates the C calls into .NET calls, and then you have the SQLite Net library, which is this ORM layer that we are actually not using. So I'm trying to make as much use of the own comments of SQLite so that we can easily leave all these intermediate libraries out.
Yeah, I like that idea.
The advantage is that because even if you work on Android has its own version. If you have an old Android version, you have an old SQLite version. If you have a new one, you have a newer. So you have all these different versions, and these libraries have to be compatible with them. And there are some important changes in SQLite. For example, the way transactions happen. Before you could only write or read at a certain moment. You could not write and read at the same time. Now they have this wall mode, write ahead logging.
Okay, yeah, so I read about that.
Yeah. What happens is, in fact, that when you write to SQLite, you don't write direct. You don't overwrite the database. You write to a separate log file. And in meanwhile, that means that other clients can still read from the database because nothing has changed. And at the moment when there are no readers, they can copy the log to the database.
Yes.
But that means the big advantage of this wall mode is that there is no writer starvation anymore. Because before, if you were reading and reading and reading, as long as somebody was reading, there was no way to start writing.
Right, yeah, you couldn't get that right lock. Yeah.
Yeah. So if we incorporate the latest version of SQLite directly in our product, then we have a stable environment and we can optimize the access and the way we work with it and test it completely, because it will be a lot of testing before it works really without problems.
Right, yes. That is true.
Because async code and then transactions and all this stuff together, I'm learning, but I see a lot of difficulties. I'm sure you can solve them, but I'm trying to solve them myself also a little bit. So with transaction, is just calling execute async. That's the async connection from that intermediate layer with the comment which goes directly to SQLite. Then it calls the callback function that we have here, and transaction, and we return the callback results to with connection.
Right.
If there is an exception, we just roll back and we throw an exception. He calls with connection. If we go to with connection, here I changed a little bit your code, because you had this exponential back off. I use the same pattern again. So with exponential back off, I just pass in a lambda function here. And then we have this exponential back off here.
Yeah.
Which just needs a function without, with a result, but without a parameter. And that calls this callback. There was one funny thing there that I needed to add an exception here, because otherwise the compiler is complaining, because the compiler doesn't see that we work in this loop. So it say here you throw, but here there is no result.
Right. Yeah. Yeah, and yeah, that's because the while and the if are really the same condition, and so as we parse it, we could see, okay, it's going to make it. It's not going to ever falsify the while condition. So yeah, you could also change the while to just a while true, and get the same effect. Yeah, yeah,
While
but you know what? I like this. I like this better than that. Now that I think about it, yeah. So with our human brains analyzing this, we can see that if I change this to while true, it'll have exactly the same behavior because once the attempt reaches the length of the pause array, then it will throw. It will never make it to the while loop to test that and then exit the while. But that's us reasoning through it and doing the math. If we got that wrong, then changing that to while true might generate an infinite loop. But what you've got here tests our math. So yeah, we're going to have that check in two places. It'll if we did everything right, then it'll never exit the while loop and never make it to that exception. But if we made a mistake, then it would make it to the exception and we would see it. So yeah.
Yeah, but it's true. If we make it true, it will improve performance.
Marginally.
Such a little bit.
Yeah, I like the safety better than the performance. Yeah.
Okay. then we leave it this way. Now because I didn't do the storing yet, but so here in the where was it? So here in this save method, I just for testing only, I just pass in a lambda that returns an immutable list of facts. So it does call this with transaction, and then I have a SQLite store test. This is just a copy of your tests. So in this case, let me see. Yeah, so I don't throw an exception here. I just so if I rebuild this, is it ready? So if I say, oh, we're still rebuilding here. Oh, and I still have to delete my database here. That's another screen that you cannot see. So if I'm still building. See there, he's there. Run.
Yeah, that's kind of the cool thing about using Docker Compose to do it. Is that it just creates the database as it needs it, then tears it down.
So this passed, of course, it passed because it's not doing anything. But I do see the database has been generated, so that's okay. And if I open it with a SQLite viewer, then the tables are in there. Then, if inside this lambda procedure, so I call connection factory with a transaction, and inside this lambda, I just throw creating my own error. Okay, I have to rebuild again. Let's see how that goes.
Yeah, so the advantage of doing it the way you're doing it is that you can take a look at the database afterward and just verify, yep, it actually did, well, in your case right now, create something, but eventually it did write something. And so far, I haven't actually laid eyes on the rows that I'm writing with the new code. I have to wait until I get the query done before I can actually complete the round trip.
Yeah. I wanted to see whether the database was indeed looking reasonably.
Actually, it could change the script so that it doesn't terminate.
And now if we go to the text explorer, still running. That's a long time. Why is he still running?
The exponential back off. It's going to throw the error and then
not that long.
Oh, okay. I thought it went up to like a 30-second timeout at the top.
Let's try that again. Was it that long? Yeah, there was a 30 seconds and then a 15, I think. Let's see.
Yeah. So if you add them all up, it should be close to a minute.
You will get there.
Yeah, which, by the way, I'm thinking about having an extra test inside of that code, so that it only does the retry on certain types of exceptions. The idea being that if there's an exception that's not recoverable, then there's no reason to retry it. So the recoverable ones are, things like I couldn't make a connection to the database. Maybe the container's not running yet, or deadlock occurred. But unrecoverable would be like there was an error in the SQL that was generated. So it's like why retry that? You're going to get the same error.
Mm-hmm. Yeah, that might be useful.
Yeah, it certainly would help in testing. You get to fail fast while you're doing the test-driven development, but you still get the protection against having to wait for the database to spin up before you start the tests and all that stuff.
Okay, 51.2 seconds.
There we go. Okay, so that's the sum of those numbers.
Yeah, so that means that it does work. That it does work the retry. Let's comment that out again here. Then there is still one thing here which I should do. So in the with connection, if the database doesn't exist, the first time when you start up the program, DB exists is false. So he will go to this create DB and create DB. He will try to create the DB if the tables do not exist. Yeah. But so after the first time DB exists becomes true. So he just tries that one time. But create DB should also be in his own transaction.
Yeah, so SQLite supports DDL inside of transactions?
Yeah.
Okay, good.
Yeah. The only problem right now is in normal transaction, you only have one level. So if I come in here with connection without the transaction, then I could immediately create a transaction, begin, create DB, and transaction. But if I call with connection from my with transaction here, then I already have a transaction running. So I have to find out whether I'm already inside the transaction or not.
Yeah. What do you think about the idea of having a separate method that's just for ensuring that the database exists? So you can call that when the application starts up. That would solve this problem because you would know that no transaction exists. You're not trying to do any work, so you would always create one. But then that would also solve the problem of potential concurrency on this method.
Yeah, it might be an easy and straightforward solution. And then and then it is more equivalent to the server code, where we have a separate script.
Yeah, it's something you have to remember to do, but a good error message can remind you.
Why not? And then the problem is solved, because in SQLite itself there is a possibility to know whether you are inside the transaction or not, but the libraries don't expose it. But we can expose it ourselves. That's not a problem.
Yeah. Yeah. Now, one disadvantage of that idea of a separate method is now you've got an asynchronous initializer. And that causes problems with some patterns. So, yeah, you'll like constructors are synchronous. You can't have an asynchronous constructor. So you couldn't really do that inside of like the Jinaga constructor. You could make the create like there's a Jinaga server, Jinaga test, Jinaga browser, whatever this factory is would be called, Jinaga client. You could make that create asynchronous, but then that causes trouble when you're trying to then put that into like an IOC container, because now you need an asynchronous initializer for a component that's in IOC. You have to have the application pause while it's doing the initialization. So what's it doing? Is it showing a loading animation during that time? And so basically everything that now depends upon it has to know that it's potentially not there yet, and it has to do that loading thing. So yeah, that does get kind of tricky. So the advantage of this is that it's already inside of something that's going to be asynchronous. You're going to be loading your data, so you're going to be awaiting that. So yeah, maybe down at the low level, it's a separate method, and then we abstract that at a higher level.
Yeah. What we could no, that's not possible. I wanted to say the first time you call Jinaga.fact, j.fact, before you call save, but you never know. There might be something before. There might be another query be running.
Yeah. In fact, I think you can pretty much count on the fact that you're going to be reading before you write.
In that case, let me try to see how easy we can get that call from SQLite. It shouldn't be difficult.
Okay.
And as the purpose is anyway to leave the libraries in between out of it, you're gonna be there anyway. So
yeah.
Let's see how that goes. Now all this code might still change, because now we are using a separate connection for every query or every data access. Now, as far as I understood, SQLite has something like an optimization in the sense of stored procedures. It doesn't have real stored procedures, but connection by connection, you could prepare SQL comments with parameters, so that it already optimizes the SQL. And so it might be interesting to have, for example, one connection for the writes and a single connection for all the reads. But okay, that's only thinking for the future.
Yeah.
In that case, we just have to rewrite that code.
Yeah. Yeah, and by the time we get there, we can measure.
Yeah, because actually, Jinaga is always using the same queries. So it might be useful that they are optimized.
Yeah, and I can easily see there being a cache layer on top of the database. In fact, yeah, in Jinaga.JS, I've got a cache on top of the database calls. So yeah, if it can serve a query out of that cache, then it just skips the database altogether. And then sometimes it does a read through, so it's like it serves what it can, and then it goes and checks to see if there's more.
Yeah. Let's see how that goes. What else did we have? SQLite. So this wall mode, I spoke about it. Yeah, that were the most important things. Yeah. Okay. So then I will look into that. Then the create database was still creating the old format with just the fact and the edge table.
Mm-hmm.
I started a create DB2 with all the new tables in it, but it's not complete yet and it's not tested yet. So
Okay.
that's another 5 minutes work. Yeah.
I like the optimism.
It's only 5 minutes, but it always takes longer.
Uh-huh.
Yeah.
Excellent.
But so I still know what to do.
Mm-hmm.
Still some work to be done.
All right. Well, you had a couple of updates, or an update to your PR, and then a new PR for the OS agnostic paths. So we got those both pulled in.
Yeah.
So those are merged. And in addition, I have been playing around with the query side. So trying to build up the query. So I'll do a share as well. Unfortunately, I've got this like in a half-built state on the Mac, and so it's
Is pull request because so I changed the data, but I never tested it on a Mac.
Yeah, I tested it first.
Yeah, okay.
Yeah.
Is there any way to run Mac OS on a PC in a virtual machine or?
There is, but it's against the Mac OS license, and doing so is called a Hackintosh.
Okay.
So not something that I've actually tried myself. But there also is Mac in the cloud. So if you want to go up to Azure or to AWS, you can reserve a Mac VM. Well, I guess it's actually running on Apple hardware so that it satisfies the license, but it's racked up there in the cloud. So that's one way to do it. And that's usually done for CI, so you can do your OS 10 builds in the cloud.
Mm-hmm. Anyway, the moment that I start developing on an iPhone, I will need to do that probably because you need a Mac also to do the final build or something.
Yes, that is true. All right, so I'm going to do share and there we go, set up all my stuff, and I've got the Mac open right here, so I can just basically retype code because this is so far not yet working, but so I'm working on the what does the query look like for for running a pipeline. So this is first of all focusing on the Jinaga.JS pipeline, the very linear one. Yeah. So to remind you, the pipeline might look like, I'm looking for s dot. Well, let me call this role so that we're not using terms for two different things. So so that step means follow wherever you happen to be. So the starting point in this case is because this is the very first step. Follow the edges toward their successors, where the role on that edge is named role. And then once you get there, filter by the field type, where the type is equal to the whatever fact type you need there. So that's going to do a successor query and get just those facts. So in Jinaga.js, this part actually is optional. So you could just say, I want all of the successors that point to me with the name role, whatever their type may be. And that's a very JavaScript way of going about things. But with Jinaga.js, there's a really strong need for having some constraints on the types. And in fact, as I've actually used Jinaga.net constraints on types, as I've used Jinaga.js, I found that I always had these types anyway. So I got into patterns where that was always specified. So that's important because our role table has the declaring fact type ID and the role name, and that's the alternate key of the role table. So so that name role is only part of that. This declaring fact type ID, we actually have to look up this type inside of the fact type table to figure out what its ID is. So an actual role ID is derived from both sets of information. And then the edge table, that has, let me take a look at the SQL database here. Yeah, that has role ID and successor, fact ID, and predecessor, fact ID. So in order to do this query, we need to join a bunch of edges together based on role IDs. So that's so knowing that type is going to be an important part of it. So so that means that I have to change the state machine that parses a sequence of steps and make it look for these patterns where it's looking for a step, either a successor step or predecessor step, and a type in sequence. So if it's a successor step, then the type follows the step, but if it's predecessor, then the type precedes it. And that's because the declaring fact is the successor. So if you're stepping toward the successor, now it's the type that you expect to see once you get there. But if you're stepping toward the predecessor, it's the type that you're stepping away from.
Yeah. So,
and then the real fun thing about that is that the pipelines that I'm generating in Jinaga.js typically do not start with a type filter. So instead, you have to grab the type from the type of the starting fact. But fortunately, you have all that information at the time that you're generating that SQL. You don't have to partially run the query to figure out what types you're looking at. You say, okay, I know the starting fact, so I know its type, and now I need to generate the SQL. So you can kind of seed the state machine with that information. So the thing that I want to generate is I want to produce very similar to how we've got in the new pipeline specification. We've got these different labels within the graph that we want to join those labels together and then select the IDs of those labels. Those labels are at the vertices where we go from joining to successors to joining to predecessors. So at the valleys, so that when we do the transitive closure, we include everything that was touched along that path. So based on those valleys, we might have I'll call this F2, fact 2. We're starting at F1. So we might want F2 fact type ID and F2 hash. Actually, now that I think about this, we already know what the fact type ID is supposed to be at each one of those labels. So it might just be that all we're querying for is the hash. Okay, I'm going to make that optimization. It's not much of an optimization, but because you're already at that row, but every little bit helps. So we're going to start from the fact table, calling that F1, and then our where clause is going to be based on the fact type ID and the hash. So in order to get to F2, we need to walk along some edges. So we're first going to join to the edge table, and we'll call this E1. And so this is going to be, first of all, on E1, since we're doing a successor join here, we want the predecessor fact ID to be equal to f1.fact ID. But now we are going to take this information into account. So while we're generating the SQL, we're going to look up the role ID. So for this, I'm basically going to have a cache of the declaring. Well, first of all, a cache of all of the fact types. So I can just look up a fact type ID by name, and then a second cache of all of the role IDs. So given a fact type ID and a name of a role, I can look up the role ID. And so that's going to be a cache that kind of persists throughout the lifetime of the application. And it's going to be very limited in size because that's just basically the size of your model description.
Yeah, the number of types and the number of roles, which is limited.
Yep. Okay. Yep. So we'll either already have that or we'll load it right now. Basically, walk this once to figure out all of the fact types that are used and then the roles of those fact types, and now make sure that those are in the cache. Load them if not. All right, now I've got the cache up to date and I've got all those IDs. And now I can work on generating the SQL. So this edge has to be this thing as a predecessor and E1.role ID And I'll take that and I'll stick that into a parameter as well. So that's going to get me from the starting fact to all those edges. And now from here, if I had more steps and more types, then I would basically repeat these. So I'd have E2, E3, E4. And each time I did, it would choose whether it's the predecessor fact ID or the successor fact ID based on the direction of that join here. And this part here would just be the ID of the fact that the previous line generated. So it starts with F1 fact ID, but if I do another edge E2, then this part isn't F1 fact ID, this is E1 successor fact ID. So the opposite of that one. So I'm following the edge and then doing that. And so then that would be %4. So so I do these edge joins, and along the way, if I get to a valley and then I need to work my way back up, then the edge join is going to look like this, except that's going to go back up, so it's going to be looking at the successor fact ID here. That's still the E2 successor, but now E3 is looking at the successor side because it's joining back up and finding the edge 3 predecessors. So we've got that, and so then we also have to put an F2 in here on E3 predecessor fact ID. So that we can grab the F2 hash. Yep. So so now we have taken edge 3, and let's suppose that now that's the end. So we've gone down to up 1. So we've got F2 at that labeled valley, and then now we need to go back up 1 to F3. So now we can join fact F3. So that's going to be on yeah, just to make things easier to read, I'll put it in that order. So we've got F3 fact ID, and so now this is going to be yeah, I think I got those backwards. This one should be predecessor fact ID. This is still the starting point. So, in fact, it might even be easier to read like this.
It's a brain twister.
Yeah. Yeah, so this actually looks a little bit more like the graph. So you're starting at F1, and then you're following E1 down, and then following E2 to the grandchild there. And now you're labeling that F2. So let's take E2's successor and call that F2. And now we take edge 3 back up. So from E2 successor up to, to join that to E3 successor. So you're going up from there. And then you're labeling that one F3. So that's your E3 predecessor. So then you put into the where clause your starting point, and then you get back out all of the labeled points that are not the starting point. So you label F2 as the valley, you label F3 as the ending point.
How many joins do you think we need at most?
Yeah, a complicated query is going to get a lot of joins. That is true. So most of the queries that I end up seeing in an actual application, this one here would be a fairly simple one. So this might be something like as user. Let's go to my application dot account. I don't know. So now this account was created by a particular user. So that's my Jinaga user. So Jinaga user would be the initial fact type ID. And so that would be information that you would get while parsing this this pipeline, but it's not actually declared within the pipeline. And then you do another s.assignment, or actually account, but the type would be my application assignment. So now from this assignment, we're saying the account is that particular account belonging to that particular user. So starting from that user, look for all of the accounts, look for the assignments for those accounts. And now I want to label that assignment because I'm about to turn the corner and I want the predecessor dot job So now this edge is the job edge. So that's the role ID is the assignment.job. So yeah, whereas right here, this is saying that the assignment fact has an account predecessor, and I'm following that down to the assignment. So from the account that I start with, follow that edge, and now I end up at the type assignment. And then this pair is saying that assignment also has a job predecessor, and now I'm following that up. And I end up at my application job. But interesting thing is that I don't actually use that inside of the query. So I'm using the declaring type account role user, and then the declaring type assignment role account, and then I'm using the declaring type assignment role job, and those are the edges. That's what I look up inside of my role cache.
Yeah. So, luckily that the computer can do that afterwards.
Yes.
Once it is programmed.
Yes, indeed, and laying it out like this, it actually makes it a pretty straightforward algorithm to do that. So every time you have an edge join, you have some previous fact ID. So here you start things off and you say the previous fact ID is f1.factID. And then when you do this edge join, you say, all right, now the previous one is e1.successor fact ID. So that ends up inside of your join clause for whatever comes next. And then you get to this pattern here where it's a successor followed by a predecessor, and you say, aha, I need to label that thing. So let's do a join to fact. Go ahead and allocate a new identifier there. Join to that previous fact ID, and then you continue along the edges. This fact doesn't introduce any new fact IDs because it's already using that same one. So that same one just appears again as you follow the edges. So it's just you're kind of dropping the fact joins in there as you go, and then following the edges. until you finally get to the end. Drop one more fact join. So your where clause is always from the type and hash of the starting point, and then you select out the hashes of all of the different labels.
Yeah. Because I was thinking there is somewhere a limit on the number of joins you can do in Lite. But I see here SQLite does not support joins containing more than 64 tables. So the number of tables should not be a problem. That's limited. No.
Yeah, I'm assuming though that they consider E1 and E2 and E3 to be separate tables. They're separate aliases for the same table.
That could be.
Yeah, 64 seems like that's enough overhead.
That will do if you don't make too complicated models.
Yeah. Yeah, because what we're usually going to be usually going to end up doing is that you'll have basically this turns into just one SQL query with the pipelines that support projections. Basically, that is now supporting the branching of a pipeline as described in the book. So you can have multiple successor steps happening from the same point within the graph, and that basically will turn into a different query for each of those graphs. It wouldn't make any sense to try to jam all of those queries into one. So yeah, given a pipeline specification as it can be described now in Jinaga.net, you basically take each one of those paths and then you can so a path declaration in Jinaga.net is a sequence of predecessor steps followed by successor steps. So it goes from one label to another. So the labels are no longer something you have to infer from the shape. They're explicit. But then furthermore, you can draw a graph of label to label, and then every time that graph branches, you generate a new set of SQL. So you end up with some SQL that has a limited number of joins based on the complexity of the graph. So those joins will probably be so here we've got 5 different joins plus the initial from, so you've got 6 tables. Yeah. You probably have maybe 10 in a fairly decent sized graph, but then you would have some fixed number of those based on how many branches are in that.
So with the 64, we are on the safe side.
I think so. Yeah.
Yeah, that's a nice quote.
Yep. And if you exceed 64, it's because from one starting point you're going pretty far in the graph. So you're pulling in an awful lot of related data, and you're doing that for basically one user interface operation. So it's like I want to show all of the so like if you had you were doing your music collection. So it's starting at you, and then it's all of your albums and maybe genres and maybe your artists. So each one of those is like a separate branch of this graph starting from you, but each branch has a limited number of edges in it. So, yeah, I think you're going to have like maybe 10, 15 of these queries that you do from the same starting point in order to populate one user interface page, but each one has no more than 10 joins in it.
Okay. I will try to draw a little bit more graphs and play with it.
Yeah. So I'll have some code doing this by the time you get to that point. But yeah, I think we're slowly working toward a good generic solution.
Yeah. No, we will get there. We will get there. The good thing is that knowledge comes in an exponential sense. In the beginning, you have trouble with everything, and as you learn more, you start to accelerate.
Mm-hmm.
I'm not accelerating yet, but I still have hope to accelerate.
Yeah.
Good.
Yeah. Yeah. I still remember that that feeling when I first got good at BASIC using my Apple II, and I could just sit in my room and code up a game, and it was like, okay, an afternoon, but now, hey, look, I can play this dice game that I play with my family. You roll the dice, you save them, you re-roll, and it's calculating score, and it's like that was an afternoon's worth of work. So yeah, being built on top of all of the hard work that Steve Jobs and Steve Wozniak put into the hardware and the BASIC interpreter, and I just got to play along on the top.
That were nice times.
Mm-hmm.
The time that a terminal was green or gray.
Yep.
No, I think I've been the disadvantage of making software that you rent out to customers is that you always stays on the same platform.
Mm-hmm.
And you maintain the old projects, but it's only when you get to something new that you catch up with the latest tools.
Yeah.
And if you bring everything together, the old JavaScript environment, which was new, then Link I had hardly touched, async and await I had hardly touched. VS Code was completely new. Yeah. In the end, every little step takes a long time, and you have to look up the internet for every letter you want to type. But yeah, like now with Jinaga.JS, okay, stepping through it and compiling it, and if it doesn't work, okay, I managed to find a solution. But in the beginning, I was completely blocked.
Yeah.
So,
yeah, and actually now with your help, Jinaga.JS is up to modern JavaScript. So at the time that I wrote it, Webpack wasn't brand new, but it was it wasn't quite where it is now. We hadn't quite figured out JavaScript modules, so we're still working on that. TypeScript was not nearly as powerful as it is now. So yeah, a lot of things have improved along the way, and so now we are finally up to actually taking all of the current JavaScript libraries except for React. We're still on React 16.
And how is, because you were using React now in one of your work projects, I think.
Yes, yeah, we're using React Native right now.
And how is that going? Still a lot of problems, or?
Yeah, I would say React Native is really not ready for prime time. It's at this point, given how long it's been in this state, I'm thinking it's probably something that I would want to skip, especially given now that Xamarin has gotten a boost, and Maui is coming up behind it. So yeah, for my mobile applications going forward, I think .NET makes a lot more sense than React Native.
Okay. Now, and I think the .NET platform, if you look at the stability, because even Android, programming on Android, I did a little bit before, was not at all as stable as .NET.
Mm-hmm.
Of course, it was also a new platform, but it was not as unstable as JavaScript.
Yeah. Yep. So you have that platform instability that you're building on top of, and the language isn't going to fix that. It might abstract it a little bit, but actually, when it comes to platform instability, abstractions might actually get in the way. So that's a lot of what I'm finding with React Native is that the platform has all the instability that we're used to with Android, and then the ecosystem is a bunch of competing open source projects, and so you're like, I want to do in-app purchases. So which one of these 3 libraries am I going to choose? Well, that one is not really supported anymore. This one looks like it's what people are using now. But take a look at GitHub, and it's got a lot of issues. Look through the code, and it's like, I don't think that's the way that you're supposed to do transaction processing. But it's like there was some learning in there. They figured it out along the way, and they made it backward compatible. And but then there's a new version 8 of that library that's about to come out anytime now, and it's like, okay, well, we could adopt that one, but yeah, or we could just go ahead and write it ourselves, because basically when you're doing React Native, you're doing the React part, all the JavaScript stuff, and then you have to do native iOS and native Android. So we could do that ourselves, but yeah, it's a challenging space to work in.
Mm-hmm. Okay. No, then Xamarin is still a good choice.
I think so. Yeah, because at least the parts that are just these 2 platforms implement in-app purchases. These 2 platforms implement animations. The way they do it is different. So there is an abstraction layer, and the nice thing is that the abstraction layer for those common things are not competing open source projects that may or may not be supported anymore. Instead, they are in the box, as it were. Mm-hmm. So that part's nice. And then the open source projects get to put their own innovations on top of those. So. So yeah,
the base is stable.
Yeah.
Okay. It's good to hear that we are still in the correct direction.
Yep, I think so.
Good. Michael, next week you will be there?
Yes, indeed.
Okay.
All right. Well, I will see you then. I thought you were just very abruptly saying goodbye.
No. It disconnected 5 seconds too early, automatically. Okay, Michael.
Very good. And now a proper goodbye.
See you next week.
See you next week.
Bye-bye.
Bye.